Swayam Prabha. Digital India. Educated India.
Hello all, welcome back. Today we are going to start with a new module on hydrologic statistics. We have completed already 5 modules related to different hydrologic processes and also hydrologic analysis. Specifically, if we are talking about hydrologic analysis, we were dealing with the hydrograph analysis. Let us start with the module on hydrologic statistics today. I will not be covering in depth related to probability and statistics in the minimal way which are required for engineering hydrology only will be included in this module. We will start with the hydrologic processes which we have already covered. Different hydrologic processes are rainfall, evaporation, evapotranspiration, transpiration, infiltration and runoff. Now, when we talk about these hydrologic processes, certain uncertainties are involved with this. These uncertainties may be arising due to the characteristics of the variables which are causing this particular process. The variables which are involved in the process called rainfall itself is stochastic in nature. That is why these processes can be modeled as random process, and hence there is a need of methods of probability and statistics for the analysis of random variables. Probability and statistics are used for frequency analysis. This is very important as far as hydrologic analysis is concerned. Let us start with probability. Probability means the chance of occurrence of an event or a random variable among a set of alternatives. For example, if you are talking about rainfall of magnitude greater than or equal to 3 centimeter, whether we will be able to state that tomorrow at 10 am there will be a rainfall of exactly 3 centimeter, it's impossible. So, these type of events or hydrologic variables can be considered as random variable. So, the probability of occurrence of a rainfall of magnitude greater than or equal to 3 centimeter can be mathematically written as Pa is equal to limit n tends to infinity Na divided by capital N. Capital N is the total possible number of occurrences and small na is the total number of observations of the particular event, that is rainfall magnitude greater than or equal to 3 centimeter. That is the number of events, Na, total number of observations of particular event. We will be having a set of data describing past data, maybe of 10 years if we are talking about annual rainfall. Out of that, we will be having the number of observations representing a particular event, and we are having the total number of observations. If we take the ratio of that and limit n tends to infinity, Na by n is representing the probability of that particular event A, probability of occurrence of that particular event A. Now coming to random variable. What is meant by random variable? Just as I have explained with the case of a rainfall, random variable is the one which can have any value between certain range. It is the variable which can assume any value within certain range. We cannot exactly point out at a particular location at a particular time this will be the rainfall which is going to occur tomorrow or any date. It can be any value within certain range. Those type of variables can be described by a certain probability distribution. What is meant by probability distribution, we will come to it, but these random variables can be expressed by means of certain probability distribution. So, probability of a random variable having a value less than or equal to a specified value, we have seen the expression, and that is denoted by P capital X less than or equal to small x is equal to lowercase p. This is the way in which we represent probability of a random variable. In this expression, capital X is the random variable and lowercase x is any value corresponding to this particular random variable. Example, as I have stated, rainfall. It can be rainfall, it can be stream flow. For example, if you are talking about stream flow, peak flow in a river, if you are considering for last so many years, based on that we can express the value corresponding to future year, that it will be within certain range. We cannot exactly tell that this will be the peak stream flow or peak flow in a river at a particular location. So that way stream flow, rainfall, all these hydrologic variables can be considered as random variable. Random variables can be of two types: discrete random variable and continuous random variable. If you are talking about the number of rainy days, that can be expressed as an integer. Those are discrete values. Number of rainy days in a particular month, it can be represented by means of integer. So that type of variables are discrete random variables. Now if you are talking about the amount of rainfall, amount of peak flow, these things cannot be expressed by means of a single value. It will be within a range. Sometimes it will be having fractional values also. Decimal values it will be taking. So those type of random variables are termed as continuous random variables. Whether there will be a flood, chances are 0 or 1. If there is a flood, the probability will be represented by means of 1, and if there is no flood, it can be represented by means of 0. So these are represented by certain numbers. So those are discrete random variables, and which are represented by means of a range of values. That particular value can be within that particular range, then it is termed as continuous random variable. Before going to the hydrologic statistics, let us have the preliminary understanding about probability and statistics. Then we will deal with the hydrologic variables. So first we need to have the understanding about population and sample. This I think I have explained during the time of rainfall related topic, but still I will repeat here. Population is a hypothetical concept which is used for an infinitely large set of a random variable possessing constant statistical properties. Population is a concept which is representing for a large number of variables. This is a hypothetical concept. For example, if you are carrying out the rainfall analysis related to annual maximum rainfall value, we will be considering certain number of years data, for example 30 years data. But population is the one which is dealing with large set of data which has occurred in the past and which is going to happen in the future is incorporated in this population, for which the statistical properties are constant. There won't be any change in the statistical values. That is why it is termed as a hypothetical concept. Statistical properties such as mean, standard deviation, etc. are considered to be constant. Sample is the one in which a set of observations of random variables. If we are representing set of observations by x1, x2 up to xn, for example, if I am considering annual maximum rainfall for the last 30 years, so 30 data points will be there, every year one maximum value. So that analysis I am carrying out for 30 years data. 30 years data is selected for further analysis. That is why sample is considered as a subset of population. Population, on the other hand, we cannot specify how many years are included in that. All the data points related to annual maximum rainfall which has already occurred in the past and also the values which are going to happen in the future is included in population. That is why the statistical properties of this population is constant. But in the case of sample, it is not constant. Means and standard deviation etc. will not be constant. That is, if you are considering a sample, for that a certain value of mean and standard deviation will be there, and another 30 years data, 30 years sample you are selecting from the population, for that different standard deviation and mean will be there. We cannot expect different samples having the same standard deviation and mean. But in the case of population, it will be having the constant value. Population is for large period, but sample is just a collection of data for some years, as I have explained with 30 years data of annual maximum rainfall. Next term you should understand is sample space. Sample space is the set of all possible samples that could be drawn from the population. For the last 30 years, if I am considering annual maximum rainfall data, in the similar way, so many samples can be drawn out of the population. Before that 30 years data, that way we can have different number of samples drawn out of the population. These set of all possible samples are termed as sample space. Now next term which we commonly use here in this subject is event. Event is a subset of a sample space. It can be defined depending upon our requirement. For example, flood. We need to find out probability of occurrence of a flood in the coming year. So the event is occurrence of flood. In the similar way, it can be occurrence of a drought. It can be occurrence of any other event. So that way, depending on our requirement, we will be defining a particular event. A flood is defined in such a way that the annual rainfall is greater than a particular value. In the similar way, if we are defining drought, for which the annual rainfall will be less than or equal to particular value. This depends on our data and also our experience. Random variable x is annual rainfall. This annual rainfall which we will be considering should be greater than a particular value in order to happen a flood. In the similar way, it should be less than certain value, then that particular year can be considered as drought year. So these are some examples of events. Now for carrying out the analysis, we need to be thorough with the different rules of probability. Probability of an event A obeys certain rules. First one is total probability rule. These rules you have already studied in the topic of probability. So just let me write it down. Total probability rule states that sum of probabilities of all possible outcomes in any trial is 1. Total probability is equal to 1. It cannot be more than 1. Let there be n events represented by A1, A2, Am. Then probability of A1 plus probability of A2 plus up to the sum of probability of Am should be equal to 1. PA1 plus PA2 plus PAM is equal to 1. This is the law of total probability. Second rule is complementarity rule. It follows that the complement of A. An event A we are considering, corresponding to that event there will be a complement. That is, we are considering an event called flood, occurrence of flood. For that particular event called flood, there is a case with non-occurrence of flood. That is what is termed as complement of event A. A is occurrence of an event and A complement is nothing but the non-occurrence of event. Occurrence of a flood and non-occurrence of a flood. If we are having the probability of occurrence of an event, then we can compute the probability of non-occurrence of an event by making use of the formula PA complement is equal to 1 minus PA. That is, the sum of occurrence of an event plus non-occurrence of an event is equal to 1. Total probability law is that total probability should be equal to 1. So, if the probability of occurrence of event is PA, then we can write the probability of non-occurrence of event A as 1 minus PA. This is the rule of complementarity. So, for example, if we are talking about probability of occurrence of the flood is 0.8, we can easily compute the probability of non-occurrence of the flood as 0.2 by making use of the rule of complementarity. Now, the third rule is law of intersection of probabilities. The probability of two independent events occurring simultaneously is given by the law of intersection of probabilities. That is, PA intersection B is given by PA multiplied by PB. PA intersection B is also termed as probability of A and B. It can be written as probability of A multiplied by probability of B. These are A and B are two independent events, then the probability of occurrence of these independent events together or simultaneously can be obtained by multiplying the probabilities of individual events. This is also known as joint probability. So, the joint probability P of A and B is given by PA multiplied by PB. Now, the next law is related to union of probabilities, A union B. If two events are dependent, we are considering two events in such a way that they are dependent on each other. So, that can be represented by means of P A union B. We can make use of Venn diagram for representing that. Two events are the event A and event B. So, the two events are dependent. So, the probability of A union B is also termed as probability of A or B. In the case of A intersection B, P of A intersection B is termed as P of A and B. In the case of union, it is A or B. So, the probability of A or B can be written as PA plus PB minus PA intersection B. Probability of event A plus probability of event B minus probability of events A and B. Why we are subtracting this particular term? You look at this Venn diagram. A completely we have taken, B also completely we have taken. One part extra coming is twice we are incorporating this central part represented by PA intersection B. That is why we are subtracting this PA intersection B from PA plus PB. That is PA intersection B by means of Venn diagram we can mark here like this. This is event A, this is event B. PA and B can be marked by this shaded region. This is the case with A and B. Probability of A intersection B is termed as P, A and B. Now, based on the principles which we have seen before, law of union of probabilities can be written in different cases. If the events are mutually exclusive and independent, that is, the events can be represented by means of Venn diagram, event A and event B, these are mutually exclusive and independent, then we can write P of A intersection B is equal to 0. From the figure itself, it is clear that A intersection B is 0. So, our P A union B, P A or B will be taking the form P A plus P B. In the case of two events, P of A or B is given by P A plus P B minus P of A intersection B. In the case of mutually exclusive independent events, probability of A intersection B is 0. So, we can write P of A or B as P A plus P B because P of A intersection B is 0. Now, next law is related to law of conditional probability. Law of conditional probability is very important when we carry out hydrologic analysis. This is based on Bayes' theorem. So, that much we are not going in detail in this particular undergraduate course, but still fundamentally what it is, you should have the flavor of that. So, let capital A and B are two events. Probability of the event B given event A has already occurred. Two events are there represented by A and B. We are going to calculate the probability of occurrence of a particular event, but the other event has already occurred. There is a condition that the other event has already occurred. Probability of the event B given that event A has already occurred. The conditional probability that event B will occur provided A has already occurred is written by P B given A. The conditional probability of B given A is given by P of A and B divided by PA. One example we can take, event A is the case with precipitation of magnitude less than 100 centimeter this year, and event B is precipitation of magnitude less than 100 centimeter next year. A is representing a precipitation less than 100 centimeter this year, and B is the event representing the precipitation which is less than 100 centimeter next year. A intersection B is event that A and B both occurs, that is 2 successive years with annual precipitation less than 100 centimeter per year. P B given A, that is A has already occurred. The precipitation of magnitude less than 100 centimeter has already occurred this year. What is the probability of occurrence of a precipitation next year which is less than 100 years, which is less than 100 centimeter in the coming year? This year what is the value that has already occurred? Given that, what will be the probability for the other event to occur in the next year? Then we are having a certain condition to be satisfied that the event A has already occurred. So, in such cases, we have to go for making use of the formula related to conditional probability. Probability of B given A is given by P of A and B divided by P of A. If the occurrence of one is dependent on the other, then P A intersection B or P A and B is given by P A multiplied by P B given A. That is, the occurrence of one is dependent on the other. We are talking about getting precipitation less than 100 centimeter in the next year if we have already obtained a precipitation less than 100 centimeter this year. That condition is there. So, for getting probability of occurrence of A and B, that is P A intersection B is given by P A multiplied by probability of B given A. That is given by this particular formula. Now, for understanding the concept of conditional probability, we can solve one numerical example. Historical data of an area shows that probability of occurrence of a flood given that a landslide has already occurred in a particular year is 0.3, and the probability that landslide will occur given that a flood has occurred already is 0.8. the joint probability of the occurrence of a flood and landslide together is 0.2. Determine the probability of occurrence of a flood and a landslide in a year. This is based on conditional probability. We need to solve the problem. We are having two events, that is, one is flood and the other one is landslide. Let us represent two events. Let probability of occurrence of flood be represented by PA and the probability of occurrence of landslide be represented by PB. PA is representing probability of occurrence of flood and PB is representing the probability of occurrence of landslide. Data given includes probability of occurrence of a flood given landslide has already occurred is 0.3. PA given B is 0.3. Conditional probability of A given B is 0.3 and probability of B given A is given 0.8. That is, the occurrence of probability of occurrence of landslide given the flood has already occurred is 0.8. The joint probability is also given. Joint probability of the occurrence of a flood and landslide is given as PA intersection B is equal to 0.2. PA given B is given to you, PB given A is given to you, PA and B is given to you. Now, by making use of the principle of conditional probability, we can calculate the probability of occurrence of flood and also probability of occurrence of landslide. From the law of conditional probability, we are going to make use of the mathematical expression PA given B is equal to PA and B divided by PB. And we can calculate the probability of occurrence of event B, that is landslide, is given by PA intersection B divided by PA by B. PA and B is 0.2, PA given B is 0.3. So, the probability of occurrence of landslide can be calculated as 0.667. Next is probability of occurrence of a flood, PA. PA can be calculated in the similar way. PA is equal to PA and B divided by PB given A. PA intersection B is given as 0.2, PB given A is given as 0.8. That can be calculated as 0.25. So, with the given data, we can conclude that there is a chance of occurrence of landslide is 66.7% and occurrence of flood is only 25%. So, this is the simple example representing the practical application of conditional probability. In this example, we have made use of the concepts of conditional probability. So, here I am winding up this lecture on preliminary concepts related to probability and statistics. The references related to this, any of the probability statistics will be including all these concepts. Related to hydrology, you can go through these references. Here I am winding up this lecture. Thank you.